Okay, so what you're seeing here is a landscape simulator that I wrote up in Python, and the GUI itself is written up in Pygame. And it's part one of 3 parts of the program. And the landscape simulator is basically a generator. It will generate training data for a neural network. And this neural network is an adaptive deep neural network, which will then feed data to create an adaptive mobile ad hoc network. So why is that important? Well, as 5G is coming out, one of the biggest problems with 5G is that even though it's really large bandwidth, it's short range and it's highly it's highly affected by infrastructure. So one of the ways around that is using something called a mobile ad hoc network. And the way that works is signals get bounced between nodes until they reach the endpoint. Currently, the best method that's being used is something called the Batman protocol. And what the Batman protocol does is it starts with your user that wants to send the message. And in this case, in my simulator, it's the blue node. And it's trying to get to the red node, which is the access point. And all the green nodes are intermediate people just walking around with devices that are on the network. So we can draw the Batman mesh. And the way the Batman mesh works is your user will send out a hello signal, and all the devices around it that are able to hear it say hello. Now, obviously, you can see here, blue is way out of range of red. So if this was a real-life simulation, it would be out of bounds. And it's also important to note that this simulator does take into account the infrastructure, which is these rectangles, and the signal gets blocked depending on how much signal is going through the building. But anyway, so you can see down below the screen the system power consumption of Batman protocol is really, really high. And that's because you have nodes like all the way up here, very far away from where the actual communication is going to take place, transmitting data to each other. And this is completely inefficient. But the problem is Batman Mesh doesn't take into account geolocation. So it doesn't know that it's so far away. And you'd think it would, but the problem is geolocation doesn't necessarily matter when infrastructure is in the way. So, one thing to visualize the best path is something called Dijkstra's algorithm. And if you are familiar with the traveling salesman problem, you're probably familiar with this algorithm. And it's the way to find the quickest path. And as you can see, the system power consumption is incredibly low here. And that's because the start node is able to bounce the signal between as few nodes as possible to get to, and the shortest distance as possible to get to the endpoint. So if you compare this to the Batman mesh, it is a lot more power efficient. But in real life, it's not really feasible because Dijkstra's algorithm takes into account that we know the locations of all the nodes around it and are able to choose the best path. And in real life, we wouldn't know that necessarily because some of the nodes that are way out here might be out of range. So what I decided to do was take a machine learning approach to create an adaptive deep neural net to be able to establish deep neural nets so that they're more efficient. And the way I went about doing that is I using this training data generator, you can program in dead spots. So, if you're in Boston, you can program in where dead spots are and where dead spots as in where you can't get a signal from 5G. And you can program in densities of people where people generally are, but you don't necessarily need that. You just need that the dead zones, and the ad hoc the deep neural network will be able to figure it out itself. So, without any training, this is my algorithm. You can see it's incredibly inefficient. The deep neural network doesn't know exactly where to send the signal to, so it kind of bounces it all around this simulated city. So, basically it trained, and the way it trained is it used Dijkstra's algorithm to bounce the signal, and it shuffled the board around tons of times, many times, in fact, thousands of times, and it was able to learn how to find the best paths to the access point. And this is the signal after training, and you could see it is a lot more efficient. And if you look at the power consumption of this, this wasn't even trained, this could be trained even further and further optimized, but if you compare this power consumption to the power consumption of the Batman protocol, it's not even a competition. The neural network is able to produce much more efficient ad hoc networks.